All right, now we're going to look at inelastic collisions, which are different from elastic in that the momentum is conserved, but kinetic energy is not. Now, typically you'll lose kinetic energy, but an inelastic collision could also have kinetic energy being gained. And then a perfectly inelastic collision is when objects stick together before or after the collision. This is where it gets a little weird because technically an explosion, which we'll talk about later, could be considered a collision, just a collision running backwards, right? Instead of two objects smashing together, it's two objects separating apart. And because of the way that we deal with things in physics and the idea that, well, technically the math works just fine running time backwards, we end up lumping them together. But we won't talk about them here. If you prefer to think about perfectly inelastic collisions as just when objects stick together after the collision, that's fine. You'll just have to amend that definition a bit later. So what you'll notice here is there's two differences. An inelastic collision does not have to be perfectly inelastic. Two objects can stick together, two objects can collide, lose some energy, but not stay stuck together. That's an inelastic collision. Perfectly inelastic is when they stick together and energy will have to be lost in that case. So this is where I said earlier, I'll draw kind of a chart for you here. You have elastic collisions. So you can say it's elastic or it's perfectly elastic, it's all the same. And then you've got inelastic. And then within inelastic, you have perfectly inelastic. So it's unfortunate that this is the case, that we use perfectly elastic and elastic kind of interchangeably when we can't use them interchangeably here. So all perfectly inelastic collisions are technically also inelastic, hence the inelastic. But the perfectly part is kind of modifying it and saying like, oh, it's a really special type of situation. And the only thing we really have to do here is usually they'll tell you energy, how much energy is lost or gained, and that'll let you figure something out. But really most of what we're dealing with is with perfectly inelastic collisions, noting that objects stick together, have the same velocity, or are one object with extra mass. And I'll show you that in a second here when we look at the example. Okay, suppose a clay model of a koala bear has a mass of 0.2 kilograms and slides on ice at a speed of 0.75 meters per second. It runs into another clay model, which is initially motionless, and has a mass of 0.350 kilograms. Both being soft clay, they naturally stick together. What's their final velocity? So initially we have mass 1 is equal to 0.2 kilograms with velocity 1 initial is equal to 0.750. And then we have mass 2 is equal to 0.35 kilograms and V2 initial is equal to 0 meters per second. After the collision, we've got two ways of looking at it. We can say mass 3 is equal to 0.55 kilograms, moving with some unknown velocity. or mass 1, mass 2 with some v1 and v2 are equal to some unknown velocity. It's really just up to your preference, what you like, whether you want to pretend they're a single object with twice, double the mass, or not double, the combined mass, or they're individual with the same velocities. The way that this looks kind of in an equation would be m1 v1 initial plus m2 v2 initial is equal to either m1 plus m2 times v final, or m1 v plus m2 v, where obviously these are the same v. So it's just whether you basically want to factor out the v or apply it to both. I prefer this first formatting, and we can now kind of do some work with that. We get that v is equal to m1 v1 initial plus m2 v2 initial over m1 plus m2. We know that this is equal to 0, so we get that v is equal to m1 v1 naught over m1 plus m2. And then you can go in and plug in those numbers and actually calculate it out. But that's the idea behind perfectly inelastic collisions. You just have to know that their velocities are the same. You don't typically have to calculate anything fancy for inelastic collisions. They'll typically just ask, is this collision elastic or inelastic? In which case you can figure that out by just calculating the total change in kinetic energy and seeing if it's 0 or not.